Hi, in this tutorial we are going to look at the properties of our basic renderer. In the rendering module and the rendering tab we have a selection of three different renderers: the basic, physical and preview renderer. The basic renderer is adequate for morphokinematic modeling. It does not require any opacity or complex physical calculations for the emission and absorption or radiative transfer from within the object with the presence of a central star or something like that. The emission is projected straight onto the image plane, and a ray is cast along the direction of every pixel perpendicular to the image plane through the object, and wherever emission is encountered it is added to that pixel. For this tutorial we have used the bipolar nebulae that we have set up in the previous tutorial on the rendering module. It is a bipolar nebula, a shell-like structure with a linear expanding velocity field. And if we have selected the basic renderer and then click on the render button, we get an image of the grayscale image of this nebula, as well as a position velocity diagram. Let's incline the object a little bit so our position velocity diagram is a bit more interesting. Therefore we click on the camera tab and set the inclination to something like 70 degrees. And re-render. Now we have an inclined position velocity diagram, and we could change the range of the velocity in the position velocity diagram. Therefore we go to the Group tab and then change the range in the velocity area to 150 kilometers per second. Now it rescales the image immediately using the old image. We re-render to recover. In the renderer tab there are several options to the basic render. First of all, there is the image size. This determines how many pixels on each side does the image have. It is set at 90, which is rather small. The normal image size that is used in this display is actually 256. We can set it to the same number. And there's a grid size in this case, and several other wavelength options, such as the minimum and maximum wavelength that we are considering. These parameters are only relevant if we are using a basic render on an object that has been set up as a physical object with radiation transfer opacity with a complex emissivity pattern. This is necessary to make it render with the basic renderer, and we will look at these parameters later when we discuss the physical renderer in more detail. The most relevant parameters for the basic renderer are the image size and the output at the bottom, whether we want images to be output PV diagrams, spectra or channel maps. We can select from these, and also related to the radiation transfer computations, there's an output for the grid, which can be output as a whole. We can add modifiers to our image. The Doppler filter is interesting since we can select a certain range that might apply to a filter in our observations. We edit this filter. Then we can set a filter profile or filter range that cuts out a certain part of velocities. In some very fast expanding supernovae, for example, we could have a velocity range that is outside the observing filters. That may be narrowband filters. Now let us have a look at the image options at the top of each of these images. We have 5 colored buttons from which we can select the grayscale image, a color image. This color image represents the color that is selected for the object in our 3D view for our mesh. If we select our nebula mesh and then change this color, the color of the mesh, go back to the render module and re-render, it will change color to red. The next button is the red-blue image, which represents with red or blue emission that has been red shifted or blue shifted away or towards the observer. There are only 2 options, red or blue. This is often helpful to distinguish between separate parts, whether they are receding or approaching. There's the next button gives a more distinct color coding for the red and blue shifted, giving a whole range which can be set. In this case we have velocities between -50 and +50 approximately. This button has an options panel which we can access by clicking on the image properties button. Here we have selected the component velocity along the axis Z, which is along the line of sight. And there's a range for the blue. The blue side will be from -50 in our case up to +50, which represents the red color. Everything in between will be represented by these rainbow colors. As we enter, say done, and then re-render, we have a more distinct coloring of our Doppler effect. The same image options are given in the PV diagram: grayscale, the mesh color, red or blue, and then the rainbow color coding our Doppler velocity. The last button is specifically suited for the physical computations where the actual spectral colors are taken into account. In this case, the basic renderer uses only one wavelength band and the color is gray. Therefore, we switch back to our original grayscale image. There's one interesting function of the renderer, which is the overlay button, which allows you to keep the original image or previous images in the rendering. Sometimes useful to see the difference between an old and a new rendering, or trace the path of an object in a sequence. Let's, for example, change the position angle in this case by 30 degrees and then re-render. We see that both images are kept in the rendering. This can be done multiple times. If we deactivate the overlay, then re-render, we recover only one of the images. Okay, this is the basic functionality of the basic renderer. Thank you.